All right, let's dive into something that is absolutely crucial for anyone building with or even just using advanced AI today. We're going to break down why AI sometimes gets so confused and, more importantly, how the pros are getting it right pretty much every single time. You know the feeling. We have all been there. You're deep into a conversation with an AI, maybe you're coding something complex or brainstorming a big idea, and then bam, it just seems to forget everything you just talked about. It goes completely off the rails, makes a simple mistake, and you're stuck starting all over again. So, what is actually happening under the hood? Well, the simple, kind of shocking truth is this. Every single time you send a message to a large language model, it's like you're meeting for the very first time. It has absolutely no long-term memory. No memory of your last message or the one before that. It is a completely clean slate every single time. Okay, so if it's always forgetting us, how in the world does it manage to hold a conversation at all, right? How does it remember that file you just gave it or the specific bug you're trying to fix? The answer is all about its temporary workspace. It uses this thing called a context window. The easiest way to think about it is like a temporary bucket. And for the AI to do anything, we have to fill that bucket with every single piece of relevant information. Our prompt, the entire chat history, any files, any tools it needs. We have to do that every single time we hit send. Now, for a simple little chat, this isn't really a huge deal. The system is pretty good at managing that bucket for you. But when we ask an AI to do something really complex, like say, figure out a massive, unfamiliar code base, the stakes get much, much higher. In fact, check this out. A Stanford study looked at data from 100,000 developers and found that using AI for these really hard coding tasks, it often leads to sloppy code, a ton of rework, and in some cases, it's actually counterproductive. It slows developers down instead of speeding them up. So just shouting instructions at an AI until you run out of space in that context window, that's just not a winning strategy. We have to make a fundamental shift from just talking at an AI to actually becoming its architect. And that, right there, is what context engineering is all about. Experts like Tina Huang define it as the discipline of actively, intelligently managing that context window. It's all about giving the AI precisely the right info it needs to succeed in the right format at just the right time and, just as importantly, leaving out everything it doesn't need. It's about being incredibly intentional. Now, this is a really key distinction. We've all heard of prompt engineering, right? That's about crafting one good message for one turn in a chat. Context engineering, that's the next level up. It's about architecting the entire evolving workspace for a huge, complex, multi-step project. It's the difference between writing one sentence and writing a whole novel. So, how do the pros get these absolutely incredible, almost magical results from AI agents? Well, it's not magic. Turns out they follow a very disciplined three-step playbook that completely transforms the entire process. And here it is. This simple but incredibly powerful framework, which developer Dex outlined, turns potential chaos into a controlled, predictable process. First, they do the research to really understand the system. Then they create a detailed plan, a blueprint. And only then, once all that is done, do they move on to implement the code. And this quote just brilliantly explains why that order is so critical. A tiny misunderstanding way back in the research phase doesn't just create one little error. No, it can cascade into thousands, literally thousands of lines of useless, incorrect code that you just have to throw away. So once that plan is locked in, we get to the implementation phase. But during this final step, the key isn't to just let the AI run free. The real secret is to actively and kind of ruthlessly manage that context window. Experts have a whole toolkit of techniques to do this. They'll intentionally compact the history, basically summarizing the progress to keep the context clean and focused. They offload huge files to an external memory so they aren't clogging up that precious workspace. They even use sub-agents to isolate certain tasks and keep everything on track. And all of these different techniques, they all serve one very specific quantifiable goal. The pros aim to keep that context window's usage below a clear threshold, just 40%. That 60% buffer, that's what prevents the errors. That's what stops the AI from getting confused, and it's what keeps the final output incredibly sharp and accurate. Okay, so that sounds like a lot of discipline, a lot of architectural work. Does it actually pay off in the real world? Is it worth all that effort?
Well, the results are nothing short of dramatic. So get this. Using this exact research, plan, implement method, one team was able to diagnose and then submit a perfect, ready-to-merge bug fix in a massive, totally unfamiliar codebase of 300,000 lines. And they did it on the very first try. One shot. And in another, just stunning example, a single developer working with their CEO used this same workflow to ship 35,000 lines of really complex code in just 7 hours. And you have to understand, this was not some simple weekend project. This was a task that a full team of engineers had estimated would normally take 1 to 2 full weeks of traditional human-only work to finish. So, after seeing all of this, what's the single biggest thing to take away? What is the real revolution that's happening here? Well, the deepest insight is this. The real competitive advantage isn't about just sitting around waiting for bigger, more powerful AI models to show up. It's about fundamentally transforming how our teams work with the models we have right now. The technology is the easy part. The hard part is the human part. And that leaves us with this final, really provocative thought. Maybe the next great leap forward in AI capability won't come from a new model with 1 trillion more parameters. Maybe it'll come from us, perfecting the architectural blueprints we give them to build from.